Bismillah Rahman Rahim. Hello and welcome to the 10th video of the Rust series. Today we will build a command line program. So we will recap all the concepts that we have learned up till now, and also we will learn a lot of new features of the standard library. So I think let's get into the documentation first, what we have in this chapter 12, and then we will continue with the hands-on development. So let's start with the documentation. So what this chapter tells us, this chapter is a recap of the many skills that you have learned so far and an exploration of a few more standard library features. We will build a command line tool that interacts with file and command line input output to practice some of the Rust concepts you now have under your belt. So I guess in the last video I have explained you how we can get the arguments from the CLI, and there are a lot of features that we can implement through a standard library of the Rust, as well as we have also create to implement a full-fledged CLI. So let's get into the documentation of the clap crate. What this crate mm, clap means, or what it does, it helps us to parse the command line arguments. So we have a lot of features into from this grade. So we can define the parser, debug, we can define the version, and then about, and so on and so forth. So this is a pretty much easy grade that we can implement directly, and we can parse the arguments of the CLI. However, we will not be using for now this for now. So instead, we will build our custom CLI tool where we will define the struct, and then we will ask user to pass the query and the file name, and then we will later uh, in return we will give users, let's say, whether they have this file or not, whether the specific word exists or not, and so on and so forth. So I guess let's get into the actual development of the CLI. So starting with the chapter 12.1, how they are telling us that how they are starting with the development. So they have started with the creating a new project. So I have already created a project using Cargo New. I have a Rust CLI project. So they are saying that how we will going to run the program and what are these arguments. So in our last videos, I have told you that after double hyphen or minus minus, we will the Rust considers that after these double hyphens you will pass an arguments, or you will pass arguments. So the first one is will be considered as query. They will be defining in later next in the next chapters, and the other one is the file name. So let's start with the reading of the arguments, how we can read or get the arguments from CLI. So starting with the, so let me zoom in a bit. Okay. Uh, and let's zoom the documentation as well. Okay, perfect, perfect. So let me remove this one, and then let me arc, let's say arcs, and then you can see we have s- you can get the intelligence. I have imported the arguments from Rust's standard library. Then you can do one thing. There are a lot of features that you can opt for, or you can use the collect, clone, count. So for now we will use collect, and then after you have, for now let's just go with the args.collect. Let me see what it does. So you can see there are type annotations needed, multiple implementations, the impulse satisfying from iterator found in the allocate. So what this means, that consider giving args an explicit type. You can see that we have to define the explicit type for this. So we can pass the vec. So what this vec type will be, it will be of vector of strings. So let me define this will be a vector of strings. Let me save it, and then the error is gone. So let's get back to the documentation. Then we have, you can see that let args vector string, they have passed that vector string. They have predominantly passed environment and then args.collect. What this DBG is a debug crate which will work same as println does. However, there is a bit of difference. It will not be cleaned as much as println used to have. Let me do it. First of all, let's test how debug macro works. Let's args and then let's do cargo run terminal and then cargo run. Oh, okay, perfect. So we have, so you can see that it's an uncleaned version of the printing or the print statement. So what you can see that you have a file name here with an arguments is equals to, what does this mean? That argument is this variable and is equals to the all the values you have passed in. So let's consider passing some arguments with the cargo run command. Cargo run hyphen hyphen and then let's just pass some arguments. Let me pass, let's say, query one or arg1, arg1, arg2. Now you can see we after the Rust considers each argument or separate out each argument with the space. So I have passed arg1 and then separated the second argument with the space and then arg2. So the Rust has automatically collected all the arguments in a vector of a string. So we have all these in the string. Okay, now let's just now what we have to do. So what we are planning, that we will be building a Rust CLI which will create file if we have it, or if we don't have it, or if we have it, so we will have to read that specific txt file. So for now, let's just create a txt file. Let's say poem or whatever .txt. I'm writing hello world for now. Okay. Control S. Okay, perfect. So let's remove this debug statement and then let's start with the creation of a file. We have already used that method or the function to create a file or read a file. So let's start with the reading a file. So let's say let content or the file or a string, whatever you want to say it, you can call it. Then fs, you can see I have just written fs, and then you can see the IntelliSense is showing me that you where you can use the fs. I can use from the standard library, I can use from the os Linux. So right now we can just use the standard library and then fs, and then what we have in the fs, we can read to string. What this read to string do? Let me close this sidebar. So in the read to string function, we have to pass the path of the file. So for now, I'll pass the static path. So what was the name of the file? Poem.txt. Let me just, okay, perfect. Poem.txt and then close it, and just let's just do one thing, debug and then write content. Okay, cargo run and then let's just do cargo run. Now here you can see I have content with an OK statement, or the, because fs read to string function will return you a result if it find if the file exists, it will work as expected. It will return the OK statement with a string of the or the content of the file, and then if the file does not exist, it will throw an error. So what we can do, you can see the type is here, the result and a string or error. So what we can do, we can do expect, and we can pass the custom message. Let's say file does not exist, or error reading file, whatever you can want to say it. Okay, so now we did one implementation of reading a file. This is a great achievement up till now. So now let's just think about something. What should be the features that we need in our CLI tool? It's not the full-fledged CLI, which will, let's say, you can pass grep or multiple other commands that you can usually do with your Linux kernel or any other CLI tool, or the PowerShell on it, or any other of the CLI or the shell. Instead, we will just use it like to read some kind of file. You can create file whatsoever. So let's just plan out things. As usual, we will open the Excalibur so that we can plan out things. What are the commands that we need to have? Okay, so it is okay. So let's start with, we will pass, let's say, let's just add the text. So we will have minus minus double hyphens, and after that we will pass the query. What does this query means? Let's say hello. Now this hello will be passed because I want to have a feature that use we can return the line where the hello word exists. What does this mean? Let me show you how. If I open the pom.txt, let me open this, and let's say we have different lines. So in line one, we have hello world with an exclamation mark. In the second line, let's say Rust uh, lecture lecture 10 hello to the uh, YT community, um, and so on and so forth. So if I pass the hello in our first argument, what we will consider that whether the hello word exists in any of the line or not. If it exists, then return that specific line. So let's say the first line we have a word hello. In second line we don't have it, so we will not be returning this line. Then in third line we have the word hello, in whichever or whatever place we have it. However, we don't consider the specific place, whether it's in on word number 2, word number 3. It should be anywhere in that specific line. So we have it in hello in the third line, so we will return the this third line too. So let's move on to the documentation. Let's get back to the documentation. Okay, now here the args function and invalid Unicode. Note that standard env args will panic if any arguments contains invalid Unicode. If your program needs to accept arguments containing invalid Unicode, use standard environment args OS. So what does this means? That standard env args will panic if there will be any unique invalid Unicode. So let's say I have some kind of other Unicodes that I want to pass in the CLI. So I have to use this function, the args OS, instead of using the args. So let's move on to the other stuff that they have run cargo run. They got to see the array of arguments. We have already tested this out. So let's move on to the second chapter, the 12.2, the subchapter of. So we have already, okay, let's just copy this. We have the content of file name, pom.txt. We will not remove the first one. Okay, let's, okay, so let's move on to the, yeah. So they are reading the file, they are printing the content of the file. So we have already learned how we can read these strings. So let's move on to the third one, 12.3. And then we have refactoring to improve modularity and error handling. So what this chapter contains, that they will cover, or they will divide or reuse their code, because we have already covered that we have to organize our codes from start. So n- we not always define everything in our main function. Instead, we will divide it into different functions. We will create different files for different functionalities and so on and so forth. So let's just go through all the documentation stuff, and then we will go back to the hands-on implementation of the CLI. So separation of concerns for binary projects. So they are split your program into a main.rs file and a lib.rs file, the library grade, and move your program's logic to library grade. As long as your command line parsing logic is small, it can remain in the main function. When the command line parsing logic starts getting complicated, extract it from the main function into other functions or types. So this is pretty much theory stuff. You can read out all the theory if you want. So let's just code this. Now what we have to do? So in the args statement, or this args variable, we will have multiple arguments. Let's say if I want to pass in 100 argument, I can pass 100 of arguments into the CLI through our CLI. So instead, we have to restrict, or somehow we have to limit ourselves to, let's say, accept the number of arguments. So let's do one thing, because we do know that in our first argument we will have the default path, and then in our second argument we will have the query, and then in the third argument we will have the name of the file. So let's start with that. So read to string. So the file path will come from args, and then let's say number 2, the index number 2. However, we don't want to get the ownership of the argument. So we will just uh, take the reference of the arguments and the index number 2. What if the argument and the index number 2 is not present? Let's see. Let me just write cargo run without passing any argument. Now you can see thread main panicked at source main.rs, index out of 1, because we only have we haven't passed any argument. So the length is 1 but the index is 2, and so on and so forth. So now we have to limit or add the different conditions. So if you want, you can define everything in that specific main function. But for now, we will not be doing this. We will create a different function to uh, read the file, to parse the config file, the configuration of a file, and so on. So forth. Same as they specified in the documentation, we can follow this documentation, or we can implement different features that if you want. So let's say to read a file, we can create a function, let's say parse, or instead parse, we can do one thing, get, or let's say parse arguments, or the parse configuration version args, and then let's just get the rec rec string, and in return be we will give two arguments in return. Let's say the first one will be uh, the query, and then second one will be the file path. So what we can do, we can return in tuple. So let's say the first one will be query. Oh, sorry. Both of the return arguments, or the return variable will be of its type string. So let's just we will not be we will not get the ownership of the arguments. And then let's just do one thing then. So let's say let new, or let's just let query is equals to args 0, and then let file path is equals to %. It will not be 0, it will be 1. Rx 2. You can return query and then file. Let's see what happens. Now you can uh, now you can define this function right above this line. Okay, now parse arguments and args. But now, okay, let's just pass the reference of the arguments. Now, this issue will remain same. If I don't pass any arguments, it will throw an error. The Rust program will get panicked because the index is out of bound. Let's see. Let's do same thing. The index out of bound. So what we have to do, we can restrict or add the match statement here. So let's say if args dot len is, let's say, less than 3, then um, we can return an empty string, let's say, or we can also do one thing. We can just add process, and it should be exit. Process exit, and then let's say we can add a print statement, print ln, and then we can, let's say, uh, you must have to pass the video is working fine. Okay, you must have to pass the to argument query managing file. Okay, let's just, okay, process exit process dot process and then exit, and it will be 0. Okay, now you can see our Rust program hasn't been panicked. Now you can see the print. And okay, one more thing. Why I have used the print ln with the prefix e? Because the e print ln will be used for error messages, and then the e print ln will always be printed if there is any panicked, if the Rust program get panicked. So now, and the second variable or the second thing is process exit. What does mean? That you have to exit the program wherever you are currently. So let's say if you have any execution in progress, so Rust will exit your program, uh, and then you won't be able to read file or further, or the Rust program will continue execution. It will not work as expected. It will exit the program. So let's do one thing, and then let's just test it out with the arguments. Let's say hello, and then the phone.txt. Now you can see we have the content of the file hello world Rust lecture with backslash n. What does this mean? This that we have a this is the next line, then a line spacing, and then and so on and so forth. Okay, so let's now what we want to do, let's just do one thing. Instead of doing this stuff again and again, instead we can define it in a struct that. So let's do one thing, uh, define it at the top. Oh, let's just define it right. Struct, and then let's say config or file config, whatever you want to say. So first variable would be a string, or let's say string file, a string. Okay, and then it's perfect, I guess. Yeah, it's fine. Now uh, instead of it's perfectly fine, and then in return, instead of returning the tuple, we will return the config. Now we have an error is config, and then query will be query to query and file. All right. Okay, one more thing, because we are returning a string, so stir- let's just get the reference. Okay, missing lifetime. There is another thing that we have, because if we want to get the reference of a field name, we have to get the lifetime into the struct. So instead of making this program complicated, let's do it simply with a string. Let's just don't make it instead of dot. Oh, rx. Let's just do one string. We have another issue. Let's just save it and then return the arguments. Now we will have config. So let's just do one thing. Config equals to, and then let's just pass the config dot file path. File path, save it, and then the first argument will be okay. So right now we don't want the first argument query. Now what we have to do, um, we have a query field in the config struct. So now we have to search for the query whether it exists in the file or not. So let's create a new function search query, and then let's just get an argument query. Let's just get the reference and then return. Or for now, let's don't, we are not returning anything for now. We will return afterwards. So how to search for a string from a file? So we have multiple tasks we can go opt for. Let's just get the string and the content as well. Content, and then it will be of type. Let's see what the type of this content is. It is of type string. So let's just get the string, or don't get this string. Let's, and then what we will do, control M, and okay, and then what we will do, we will search for the query parameter or the query in the file content, the string. So we have multiple functions for that. So let's say result is equals to, and then we have multiple stuff. So we can read line dot contains function we can use for that. Let's go for fs, and then read line, or read to string. There are multiple functions, or we can go for, let's just go back to the documentation. um, do we have a function right here? Let's get the, okay, so what they are doing, okay, they are read to string. No, we don't want this. No, right now we are not doing anything. Okay, so read to string file path. Okay, so they are searching and getting, okay, looping over, they are looping over the content. I don't want this. I just want to get a function if they have it, or we will search for the function on Google. Okay, so content dot lines, we have this function. Okay, so content dot, we have a lot of functions with the lines. Now what we have in the lines, let's just do one thing. Lines will, it will return the lines. What we have it in lines, let's, lines will have a map split inclusive characters lines map. Let's just go to the lines map. Lines map has a struct lines map implemented lifetime function. This is a closure. We will uh, learn about closures in later a while. line dot strip suffix, they are stripping the backslash, and they will um, strip. What does this mean, strip? That wherever they find backslash, and they will consider the previous line as a first index, then second, and then let's just do one result. Okay, but for, let's say, line in result, print ln line, and then let's say, okay, search for a query, copy it, and then paste it right above here. Query, let's say config dot query, and then content dot, sorry, content. Let's just what we have arguments to this function are incorrect. Okay, huh? Yeah. So what we are expecting is the shared reference of a string. So right now I have passed the, okay, now it's perfectly fine. Let's just do cargo run. So line 1 has hello world, line 2 rust lecture 10, and then list goes on. We have an empty line as well. So let's just find, let's say, line dot contains, what we have to find, the query. If it contains, let's do one thing. If line dot contains query, then print ln, let's just line exists. Let's just go and search hello. How many times we have it? Line exists, line exists. What does this mean? We have hello in two lines, first line, second line, and there is no hello in any of the line. What if I pass hello in its small case, let's say in lowercase? Oh, it didn't find it. However, we have hello. So what does this mean? That this line dot contains is strict with the case sensitivity. So it will check for the case sensitivity. So if whether the case, it should be whether the query is uppercase, so it will find the same word with uppercase, and then it follows with the other text cases as well, whether it's lowercase, capitalize, and other. So what we can do, we can do one more thing to lowercase the query, as well as, let's just do one thing. We can, we have case sensitivity right here. So what we can do, we can uh, do we can add the, or we can make the content in lowercase, convert the content in lowercase, as well as convert the query in lowercase too. So let's just do one thing. Content lowercase, okay, save it, and then okay, one more thing. Temporary value dropped while borrowed creates a temporary value which is freed while still in use. So this, there is another issue. Instead of doing this, result dot lines, and then let's just do one thing, dot to your base, and then the same issue. The trade bound string pattern is not satisfied, required for a string to implement pattern required by a bound introduced by this call. Consider borrowing here. So we have to do borrow, and then we'll work. Now it does not checks for the, or it is not case sensitive right now. If we pass capitalize, it will work the same. If we pass in lowercase, it will work the same as expected. So now instead we want to return the line. So let's just see whether it will return something or not. Contains will return boolean. What does this mean? Whether it exists or not. It will return true or false. Line dot contains. So what we have to do, we can print the line. Let's say at the statement and then at the line. What line it is? What's the content of the line? Now you can see line exists. Hello world. Line exists. Hello to the YT community. So now we have achieved a lot of stuff. Now we can do one more thing. We can implement a lot of different functions, and we can also do one thing. We can split these stuff into other files as well. Okay, let's just do one, replace it with one. One means please exit. Uh, Okay, now one more thing. We have already discussed that dot expect method. Um, the dot expect method sometimes or sometimes it will uh, return. Let's say if the file does exist but there is some other issues, the program will get panic. So instead of to preventing these kind of issue, we can use unwrap or else. Unwrap or else, what does this mean? If the function gets the okay result, it's working fine. If it is not, then we have to pass a return statement or the whatever you want to do if there is an error case. So let's say I will add a closure. Now what does closure means? Closure is kind of it's kind of anonymous function, same as in JavaScript. So let's get an example. So let's say const, let's say where is equals to abc. One, let's just do one thing. abc cde fg, right? Okay, and let's say dot map. Here you can see we have a function map, and inside that function we can get multiple arguments, let's say underscore id or the index, and then the fetero function, and then we can whatever we can do, we can return something, we can implement some functionality and do return statement, same if we are working with JSX or TSX. So this is the JavaScript syntax for the closures. So closures is kind of the same thing. Okay, let's just close this side. Okay, now what we can do, we can add the curly braces and we can implement any of the functionalities we want. Let's just print error and println, and then let's say failed failed to read file, and then that's okay. We have an error, expected string found nothing, or the curly braces mismatch types. Where we have mismatched types, we have here. So what does this means? That let me show you. So in the unwrap or else, we have self. The first argument is the self, and then second argument is the operation. What's the operation is. So let's move on to the examples that how we can implement the unwrap or else. Unwrap or else, the first is the count or whatever you have to work with, and then the second argument is the operation that you have to perform. So let's say, so what does this mean? That we have to pass the operation. So let's say we can add the process, we can exit the process. Let's say after printing that we cannot, the Rust program wasn't able to read the file, and then let's just exit the CLI program, same as we did uh, here. You can see if there is not enough arguments that we want in our CLI, so let's just exit the programs peacefully, kind of thing. Exit and then add the one. Let's just save it, and error is gone. And then let's say like txt1 just failed to read file. It's peacefully exited. Now one more thing, because you can see there are the code is becoming messy, so we can uh, split out these functions. Let's say content of this file can be splitted. So let's say we can create a function, uh, so where we will pass the file path, and in return we will get the content from that. So let's create a function. We have parse args function. Okay, so before moving forward, let's just instead of parse args, we can create, because we have a strict config and in return we are getting the config struct. What we can do, we can implement this struct. So implement config, and then let's just add this function into that parse args, and then instead of parse args, we can do new, and then what happened? Where is the error? Yeah, right here. Parse args. Instead, we can get, let's say, initially we can just pass the config. Yeah, config, and then let's just pass query args, args one, and file path and person args. We can do this thing as well. However, it is expensive because we have already implemented the same logic here. So we won't do anything like that. So instead we can do, uh, we want to have this config function with a new now. So what does this mean? How we can implement that functionality? So we can implement the same functionality. Let's say, let's come here. Video is working fine. Okay, perfect. So let's just pass the arguments. Now we have the arguments and then function. We have implemented the config struct, and then we have passed the arguments. Let's just get back to the documentation. What we have in the documentation. Okay, so we have search functionality on which chapter we are currently. Okay, on 12.4. So we have we did the same implementation. However, we have lifetimes here. Why we have lifetimes here? Because of the contents. So we will implement the same functionality if we want. Let's just do one thing for now. Let's just move this functionality to a separate function so that we can clean out this mess. Okay, so let's say function read file. We want to let's just get the first argument or the file path. So file path will be of shared string. Okay, and then in return we will return the string. Okay, and then let's say, let's just copy this, cut out, cut this, and then paste it here. Okay, now file path fs colon read to string, and then return content. Okay, config, not file path, instead just do file path. Perfect. Insert and add the error as well. And and we can directly pass the error. It's fine. Let's get, okay, we are on error. Let's get here search query. Yeah, we will implement that. Read file, go back. Okay, now we will have content equals to read file, and then read file will, let's just file path. File path will be from config dot file path, but we will share a reference. Okay, Now search query will, now let's test the functionality, whether it's working fine. Fail to read file, no such file or directory. Let's just see. Okay, now we have line access hello world. Okay, so instead of doing this, we can line access, so we can do line. Okay, now we have a lot of stuff right here. Let's say let line and index, whether index exists or not. No, index can be accessed because expected type string found tuple, we won't be able to uh, get the index. So instead we can iter into iter and then enumerate. Okay, now we have it. No method named contains found for type use size in the current scope. Yeah, we will implement this. We will fix this as well. So now what we have into, okay, so into and from are from the later chapters. Let me note, let me simplify it. Let's get back to the older implementation now, because it will become more complicated as we move forward with the into and from. These are the traits. We will learn about that in future in the upcoming lectures. So how we can move from one type to another, how we can convert a specific type to these another ones, and so on and so forth. So let's just not complicate anything. If we want to pass the index, we can add the index right here. Let's index and then increment, do an incremental uh, stuff. So let's just do one thing. Okay, now here, let's get back to the documentation, what we have right now. Okay, so they have implemented the test functionality too. So right now, I don't want to by complicate stuff by passing the lifetimes, because there is no need of lifetimes in our Rust program. They have implemented the lifetimes because the requirement was here. Let me show you where they want to. Let me show you. Go back to the previous chapter, the chapter 12.3. 47 minutes is already. So let's just quickly wrap up this. Okay, so they are config, build, arguments, unwrap, or else. We are mostly doing most of the thing are same. Okay, so they are getting the config, and then they are config dot file path, and they are doing this. So instead, we are not doing the same. We are just parsing the argument. And one more thing. Okay, so l- instead of implementing where is this unwrap or else, they did one more thing. Let's just add the um, question mark operator. What does this mean? Instead, let's just don't pass any of the thing. We will have an expected struct string found enum result string stdio error. So instead we can do one thing. I'm not trying to complicate it. I just want to simplify it. However, I just want to explain the concepts as well. So result, and then result के अंदर you will have the OK statement, which will be of type string, let's say, and then error will be of type stdio error. However, from start we don't know whether the error is from the file, let's say whether the file exists or not, or it's just a random error from our, let's say, uh, there might be error from the operating system. Let's say Ubuntu supports something, Linux supports something, whether Windows supports something. So instead we can do dyn. What does this dyn means? This dyn means dynamic. What does this mean? That we will have dynamic error. Let's just error. Okay. One more thing. Let's just get back to the what does this box mean? We have to box it out. A box is kind of a let me show you what this theory. Now you can see pub struct box. It's a struct a pointer type that uniquely owns a heap allocation of type T. So it owns a memory block kind of a thing. You can see it owns a heap where you can store the dynamic error. So now let's because we will if we add the question mark operator, what does this mean? If the result is okay, then return it, or else just throw an error. So let's just do one thing right here. Expected enum result string box static error found struct string. What does this struct string means? We have to pass. We can go and let's just return okay and okay in general content string and let's just and it will work fine. And if I want yeah, right here we won't be able to directly pass the string because we have a string or box error, and now we are complicating stuff. So instead of complicating this, let's just simplify it by moving to the older logic. But however, I will not um let's just copy it and let's just add do control Z to simplify the logic. Okay, now let's just add this and copy it, comment it out. Okay, so l- so this is perfectly fine. We have already built a lot of stuff and it's perfectly fine. We have covered mostly everything. Yes, this is fine. This is fine. We have simplified everything. Okay, perfect. So let's just implement testing. Let's just do the testing as well as let's just move it into the library grade because let me move this to library grade, library lib.rs, create a new file lib.rs and let's just copy this import functionality. Oh, sorry, let's just import it. One more thing, save it and then let's just config. Okay, perfect. Read file will be here, search query, perfect. Okay, let's just remove this. Now we have an error that config is not available. So now what we have to do, we have to import the config, but it is not available because uh, by default the Rust behavior is for any of the thing it will be the Rust behavior by default. Every struct function will be private. So we have to make it public pub and add public. Let's just add the public in the function, add pub, and then public, make it public here as well. Let's just go back to the main.rs config, the CLI config. Let's just get this. Perfect. We have it. Let's just do the testing. Uh, it's right now 53, 58. So let's just speedily work on that and let's just wrap it up. For testing, we have a default uh, command or syntax conf. What we have conf texting, sorry, conf the configuration and then the test. Let me go next. All right, yeah, right here we have CFG, my bad, CFG, and then implement test. And then let's, you can call whatever you want. you can name it whatever you want. Let's say CLI testing, and let's start with test one. What we have, let's just use super. Okay, and then let's just test function test uh, search feature. And in this function, we will have, let's say, we will, let's just read a file. So for that, we have to read a file. Let's just copy both of these lines for now. Search query. Okay, so one more thing, content. Okay, let's just pass the static type home.txt, and then let's just pass the query. What should be the query? For now, let's just pass hello. Okay, it's perfectly fine. And one more thing, because we are not returning anything, so we won't be able to add the assert here. So instead, we should return line. Let's just return lines here. So because we have to return, let's just return. Or we can do one more thing. We can push into, let's create um let's say output, and it will be of type vector name. Let's just assign the type vec, and it will be of type string. Sorry. Okay, now let's just output dot output dot push, and then we have to push the line. Let's just return. Okay, so now we have expected string, found reference of a string. So instead of, let's just do one thing. Let's just pass the reference of a string. One more thing, we have expected a string. Let's just save it first. Okay, now we have another cannot mutate immutable because we haven't mutated. Make it mutable and return output. Return vector string. Now we have another issue, missing lifetime. Specify this function's return type contains a borrowed value, but the signature does not say whether it is borrowed from query or content. So it does not know whether the borrowed value, which borrowed value are we returning. So we are returning from the content. You content is assigned to result.lines, and we are returning the result, and result is directly connected assigned by the content. So let's just do amper take a, let's just take a. Okay, and one more thing, take a. What happened? Okay, perfect. Now we have output cannot return value referencing local variable, returns are value referencing data owned by the current function. Let's just return the reference of that. And one more thing, let's just do one thing, and then expected struct. Okay, wait, let's save it. Okay, now result is borrowed here. Result is borrowed here. So now what does this mean? That result is borrowed here. What we have to do? Let's just get back to the documentation and let me explain. What does this? Oh, what is happening? Left chapter 12. Okay, now get back to the same thing where it is the borrowed thing, the lifetimes. This is not the same thing. Where is have to explain the concept. Let me just really find really quick. Okay. So here, it's not the same thing. Let me find it really quick. Okay, I have found it. So we have this function here. So where we have query with, they have already implemented the lifetimes here. So now what they are doing here, they are directly getting the query, making it lowercase, converting it into the lowercase, and then instead of converting contents to lowercase first, what they are doing, they are directly converting the line to lowercase and then adding the, let me go back to the code right here. So what, instead of doing, making the content to lowercase, because we are getting the error here, cannot return value referencing local variable, we are getting the reference of this content variable, and this is not allowed because we have already implemented the lifetime. So lifetime is implemented on the content. So instead we can do one thing. Let's get here and let's just make it at the lowercase functionality, lowercase implementation here. And now the result, it cannot find result because we don't have result. Instead we have content.lines, and then it will work as expected. So now let's move here. Let's get back to the, get back here. Now we will have, in return we will get an array or vector of strings. So let's do one thing. Let's say search search content, and let's say let's just do hazard, and we will have two lines. So what we are expecting, let's go back to the poem. We will expect two lines, line hello world in first line, in first index, and the where is poem.txt. Let's just close this. Hello dot video is working fine, perfect. Okay, now hazard equals to, let's just implement equals, and then we will implement the search content. Let's just add the cargo. Let's just run the command cargo test. Okay, so we have variable does not need to be mutable. Now here cannot compare string slice with vector of string slice. So no implementation for, because on the right hand side we will get vector and then the reference of a string in each index, and we are passing ampersand string with vec2. So instead we can do one thing. Let's do one thing. Let search, or let verify content back new, or instead we can do one thing. Let's just vector. Okay, we can also do one thing. Instead we can pass vector. Let's just pass this here, and let's just cargo run, cargo test, and then one test passed. The test is passed. Let's make it, let's try to fail it. Mm, I have changed the query, the left hand side hello world one, however the right hand side is hello world. So this is pretty much it from that. If you want to test, let's say, whether we are getting the file, let's just add one more function. Let's just test this function really quick. Read file. Instead, let's create a separate function. Um, phone.txt, and then in the content you have choice. Let's just content, and then for for testing this, let me just add a print statement really quick here so that I can, or just add the print statement really quick here so that I can copy and paste println content, right? And let's just add the cargo, run the cargo test. We have, oh my bad, let's just make it, try to fill it. Where is this? Let's just fill it. Okay, now we have it. Let's just copy this. Content and world. Hello world, hello to the community. Yeah. Let's save it. Right there. Content test. Uh, let's just do one thing. Read file test, read file test, or test read file test. Okay, read file, and then let's just go and yeah, right here, cargo test. One passed, one failed. Left is backslash n and so on and so forth, and then the right hand side is, let's just copy this right hand side. So we are expecting this to an admiring Bob, and then add line spacing here. Both of the tests are passed. So here it is. We have tested the CLI application. We have also um, mm, distribute, or we have also uh, made the code reusable. It is reusable. It is working perfectly fine. So I hope you have learned a lot of concepts, new concepts from this video. Let's just read out the summary really quick. Writing error messages to standard error instead of standard output. So what they are doing here, they are implementing theeprintln. So we have already done these kind of stuff because I was trying to make it very useful for you instead of reading and copying pasting stuff from the documentation. So the summary includes this chapter recaps some of the major concepts you have learned so far and covered how to perform some common IO operations in Rust by using command line arguments, files, environment variables, and the eprintln macro. For printing errors, you are now prepared to write command line applications combined with the concepts in previous chapters. Your code will be well organized, store data effectively in the appropriate data structures, handle errors nicely, and be well tested. So now we have already covered closures. We got you got some hint about from and into macros, and then we have also uh, reviewed the standard errors, eprintln. We have recapped the concept of lifetime structs, implementation of these structs. We got to know about debug macro, dbg exclamation mark, the debug macro, and there are a lot of stuff that we have learned from the today's video. And I have also let told you that we can implement the CLI through this CLI parser. The the name of the crate is clap. If you want to use it, let's go and let's just to run this command cargo add clap. The clap crate will be added directly to your cargo.toml file. If you go in the cargo.toml, and then you can see clap and then the version here. So you can implement the clap create as well. You can just parse the arguments if you want to show, if you want to show users or display users that what are the options that are supported by your CLI. So you can add it right here, a name, count, what are the arguments that are required to be entered by users. So you can do this directly through the CLI parser tool or the create clap. So I hope you have liked this video. You have learned a lot of new concepts from this video, or refreshed the older ones. So if you have liked, or you if you find this video if you have find this video useful, just share it with your fellows, as well as subscribe or like this video and channel. And if you have any queries, just let me know in the comments. I'll try to address your queries as soon as possible. If the if possible, I would love to bring that specific query into my video so that we all will learn from your questions. And you can follow me on my socials as well. So let's just wrap up this video and see you soon in our next video. Let's bye.